Okay. So, uh, what we're looking at right now is the assignments page, and Jonathan tried to communicate with me over the weekend, apparently, and I was not checking my inboxes religiously, I guess. So I missed that. Apparently, I had not published Quiz 8 Prime Time, despite announcing it with great fanfare. So, uh, or at least I made an announcement. If you didn't hear the bugles, then um, that didn't work either. No, there were no bugles. Um, so, in any case, um, this is a little bit tricky, the primetime thing. So um, pay attention to detail there on some of them, I guess. I'm thinking it's correct. And then midterm part one, there's different styles of problems, so I'm trying to build up my palette of templates. So that matching problems, fill in the blank, number problems, and that sort of thing. I think the last one I did was a sequence of 8 true-false things where you're just looking at the value of a Boolean expression. Uh, and so that's all sort of beginning stuff, and I'll try to, so that's like the first 4 weeks maybe or something in there. Um, and I will try to make a part two. The idea being that we get familiar enough with this venue so that we can say we did something in that arena, in the testing arena. Who's going to test the test? I guess that seems to be the question for the virus. uh, so, well, let me get the chat room going here so I can maintain that. Chat room. I guess I have to go to. Oh, it's not available. It must be available. So, yeah, this is the Zoom thing, and I've got. Oh, here it is. Okay. Uh, and we've got import format. Is that what that is? Oh, a little Go. Yeah, right. Some Go code. So, right. So you're declaring fib to be a object of type func. Is that it? Which takes a func object? I'm not sure. That's interesting. Yeah. Uh huh. So B is assigned to A and B. Oh, I see. No, that's like a dual parallel assignment, right? So A plus B is assigned to B, and B is assigned to A. Right. That's an interesting way of recursing the Fibonacci. Right. Cool. Very very nice. Um, I think C++ may have some features like that. Um, there are tuples. You can have the output of a function be a tuple. Um, so there's a lot of flexibility introduced in C++ 11 and 14 that I don't always make use of, but it's there. In any case, let's go to the discussion. I'll try to move this up to the top, which is, I guess, the bottom. I don't know. I think of that as the top. And open this and maybe make a agenda. So here we got agenda for 427. So anybody, I'm just curious, anybody in a science class? Like chemistry maybe? No? Okay. I'm just wondering what that. I'm getting a little bit of feedback as to what's going on with their labs. Um, but doing labs online in science is just not the same as. Well, I guess there's a lot of classes like this. Welding, right? At some point, people got to weld, and uh, not easy to. I suppose you can get the VR thing going, right? Jonathan has some experience with the VR thing, right? Um, oh, really? Okay. Okay. All right. Um, yeah. There was talk about nursing, having a big VR component. I'm thinking, I don't know if I want somebody who was trained with VR, like mucking with my bod. But yeah, all right. So we got an agenda coming up here. Is that what I'm? Oh, I think I have to scroll up here, huh? Oh, and it's still not visible. Okay, so I think I have to scroll that down. Okay. Um, all right, that seems to work. And so here is item number one, and yeah, I don't know. I find it necessary to orient myself to what's at hand by doing a little Kattis warm up. All right, and then we need to do chapter 7 from Stroustrup, which is finishing the should we say what that is? Completing the calculator, and then we should probably do some myopen math just to see how that's going, and I don't know. Is there anything else? There probably are some other things that should be going on here, but we could. This is a flexible agenda, so that's a start. All right, I'm going to post that, and yeah, I should be looking in my inbox, and here is yeah. Oh, yeah. I guess we have to do that. Game of life. Okay, so So I guess I don't see a brand new email from you. I wonder. Maybe it went into my inbox and. Oh no, there's a spam alert. Apparently, Brittany Braxton wants to sell me some stirs. Yeah. Did you follow the price of oil going negative? That was. I had to laugh at that. All right, and oh yeah, here's a little discussion on labs. This is a chemistry instructor here, describing in some detail the failures of Labster, which I think I said was analogous to a chimera. Oh, these things don't open properly, do they? Okay. But yeah, I was reminded of the computer science aphorism that if it doesn't have to be correct, then it can be as fast as you like. Right. In any case, yeah, Kattis, okay, let's go. Why not? And Kattis problems is where I usually find my inbox to that, or inroad to that. And I think I want to log in. Can I just do that by memory? Seems to remember something there. Okay. And problems? And do we want to sort by difficulty? I guess so. That's what we do, right? But let's try to get more points. I don't find that the difficulties are necessarily perfectly aligned with true difficulties. So shall we try this Watchdog one? I'm sort of waiting for Dave to say, I've done that one. Oh, look, we've got a new participant. That's Kenny. Great. How was your weekend? Good. All right, so Watchdog looks like that's a go. That's the first in the 2.0s, right? So our company, name withheld, has an office building at the center of Lund. That's in uh, Sweden, maybe. I think, yeah, like northern Sweden. This is oh yeah, Northwestern Europe programming contest. Okay, from Mikael Goldman. All right. Can you? Yeah, right. That's on the right side here. Okay, I need to get rid of my list of people. Alrighty, there we go. And all right, that looks good. So the building has a perfectly square roof with a number of hatches. Because of a series of burglaries where the perpetrators have entered through these hatches, it was decided to use a watchdog to guard the hatches. A particularly vicious but rather stupid breed of dog was chosen, and unfortunately the dog fell off the roof on its third watch. Oh dear. A new dog has been procured. It has been decided to attach a leash to its collar and attach the other end at some point on the roof. However, if the leash is too short, the dog cannot reach all the hatches, and if it's too long, then the dog will fall off the building again. The leash has hooks at both ends, so no part of it is used to tie knots. All right. The company wants the dog to reach the center of each hatch. The dog can reach exactly as far as the leash could reach if it were lying flat on the roof. The center of each hatch. All right. But it does not want the leash to extend beyond the edge of the roof. To the edge is okay. To the edge, but not beyond the edge. They hope that by carefully choosing the length of the leash and where to attach it, the dog will be able to reach the hatches without risking falling off the building. A leash can only be attached to a point with integer coordinates. If the building is 10 by 10 meters, then the southwest corner of the building has coordinates 0, 0. Southwest. Well, that's our usual math concept of the origin, right? And the northeast corner has coordinates 10, 10. A leash cannot be attached at a point where there is a hatch. All right, there is no place where you can attach a leash, reach all hatches, but not reach beyond the edge of the roof. If there is no such place, then it is impossible to use this breed of dog, and the company instead will use a poodle, which is a less vicious type of dog, but also less prone to falling off buildings. All right, I'm not sure I understand. I got some of that. So the input, on the first line of the input is a single positive integer, which is the number of test cases. Each case starts with a line with two integers, s and h, where s is a number between inclusive 2 and 40, and h is a number between 1 and 50 inclusive. S is the side of the square roof in meters, and h is the number of hatches. The following h lines each contain two integers, x and y. These are the coordinates of the hatches. Hatches will never lie outside the roof or on the roof's perimeter. No two hatches will occupy the same location. For each test case, this is the output. Output one line containing the coordinates x, y at which to fasten the leash. If there are several possible points, output the one with the smallest x, and if there is still several possibilities, select the one with the smallest y among those with the smallest x, such that a leash of suitable length allows access to all hatches without extending beyond the edge of the roof. Oh, that reminds me. I think I'm going to have to make some drawings. It sounds like an occasion for drawing. And so I want to open a GIMP image. Open recent, maybe? Yeah. Oh. I think it's this one, huh? Okay. And I think that's then in here. Okay. Let's see if that, yeah. All right. You can't see what I'm looking at, so let me go back to the input. Okay, so I'm going to go to the code window and open a new file, add a new item, which is going to be, what is this thing called? Mad Dog or something? Watchdog. Okay. So I'm going to call this Kattis Watchdog. And this is going to be then me. You can be you, as usual. Doing the Kattis Watchdog problem. And let's get a statement of the problem, which we can reread, because we think we're going to need to, right? Okay. So I'm just copying onto the clipboard the problem, and I'm going to paste it in here. Okay. And is that's reasonably visible? I think I want to be like that. Okay. Do we want to zoom in a bit, maybe? Okay. All right. So, yeah, Lund. The building has perfectly square roof because of a series of burglaries, yada yada. Guard the hatches. Vicious dog fell off the roof on its third watch. A new dog with a leash. And it has to be attached someplace on the roof. If it's too short, you can't reach the hatches, but if it is too long, the dog falls again. The leash has hooks at both ends, so no part of it is used to tie knots. That's a simplifying assumption, right? So we want the dog to reach the center of each hatch as far as the leash could reach if it were lying flat on the roof. It does not want the leash to extend beyond the edge of the roof. To the edge is okay. So by attaching the leash at the right place, you can reach all the hatches without falling off the roof. So if the building is 10 by 10, then the southwest corner is at the origin, and the northeast corner is the opposite extreme of the roof. Okay. A leash cannot be attached at a point where there is a hatch. If there is no place where you can attach a leash, reach all the hatches but not reach beyond, it is impossible to use this breed of dog, and the company will instead use a poodle, which is a less vicious and less prone to falling off buildings. Okay. On the first line, you're going to get n, which is between, well, it's a positive integer less than 100, which is the number of test cases. Each case starts with one line and two integers s and h, where s is even between, I have this idea that that's a Unicode character, but I'm not sure. The less than or equal. S is the side length of the roof. H is the number of hatches. And then you get the coordinates of where the hatches are. And no two hatches will ever lie outside the roof. So basically, you know, no worries, right? Output for each test case, output of one line containing where you attach the leash. And you want that to have, of all the x coordinates, the smallest, and if there are two smallest x coordinates with the same y, pick the smallest y. Not extending beyond the edge of the roof. There's no such point. Output poodle poo for that test case. So here's some sample input and sample output. So we're going to have 3 test cases, and the first one, what is it? S and H. So it's a 10 by 10 roof with 2 hatches. The next one is a 6 by 6 roof with 6 hatches. And the final third one is a 5 by 5 roof with 4 hatches. I got to go back to here because it doesn't look like that. Oh, I guess that is. Okay, I'm sorry. So we have 10 by 10 roof with 2 hatches. And these are the coordinates of those hatches, right? Hatches. Then we have a 20 by 20 roof with 2 hatches. And these are the coordinates of those hatches. Then we have a 10 by 10 roof with 3 hatches, and here are the coordinates of those hatches. And here are the outputs. So for this first one, I guess we'll put it here. So this is the where do you attach the leash? Okay, let me see. Do I have I'm just thinking, can I draw? No. So which one of these is the... So I've got the code window up, and I've got... okay, I think I have to just choose the properties to associate that with the GIMP window, which is here. Okay. So now if I put my focus here, nothing. Why is that? Oh, hang on a second. Yes, sorry. So I'm trying to make this paint window. It's not actually, it's a GIMP window, but it's called paint in my program. And okay, so I've got the webcam, I've got the VS2. Oh, do I need to move this up? So if that's okay, yeah, that was a problem. Okay. So yeah, okay, let's finish organizing our outputs here. So if we have a 10 by 10 roof with 2 hatches located here and here, then for some reason, so should we figure this out? So if we got 10 by 10, I don't know, is that, let me make my paintbrush a little bit thinner. Size is currently 14. If I bring that down to like 8 maybe. Okay, So I'm going to attempt to draw a 10 by 10 roof here. Yeah, and so the halfway point would be 5 and 6, 7, 8, 9, 10, right? And perfectly evenly spaced hash marks, I might, mention. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so what are we finding out here? We're finding that there are 2, and they're at 6, 6, so there's a hatch here, and there's a hatch at 5, 4 here. Okay, and they're saying, should I change the color of this thing? I don't know. How hard is that to do? Put my brush over here. Color options? It's kind of a gradient thing. Okay, I don't want to necessarily change the options. I just want to change the color. I see. There's the hardness. Where are the other windows for GIMP? Put them over here. Okay, so this is OBS backdrop, Paint Dynamics editor layers. Oh God. And then there's. Okay, I think this is what I want, and so if I click on that, can I make it blue, say? Okay, and then when I paint, so they're saying that the 3.6 is where we should put the hat. Oh, that didn't come out blue after all. Oh, I see, that's the background, so let me, oh, can I undo? Oh dear. I think I want this color, the backdrop, okay. Well, I guess, oh, can I just swap those? Okay, so now 3.6, yeah, see, that's now blue. Okay, so that's where I'm putting the, okay, does that make sense? Sorry, is that even sensible? So that's at 3.6, right? That's where I'm attaching the leash. All right, and I think so. What is the distance from 3.6 to 6.6? Well, that's 3, right? So this distance here is 3. What's this distance here? And that will then, if it's a leash of radius 3, and that's what they're saying. Oh. Yeah, they're not saying what the leash radius is. They're just saying where you would attach it so that you could have a leash long enough to reach all the hatches without falling off. And it's got to be an integer coordinate, right? Why not put it closer to these two things? Like at 5, 6, say. Then you could have a shorter leash. It seems to feel like I'm missing something here. So 3, 6. Oh, because you want the smallest x coordinate that will work, right? And of all those x coordinates, you want the smallest y coordinate that will work. So if you were to say go 3, 5, what's the problem with that? Well, so this is 3, right? What's this length here? We're going from 3, 6 to 6, 5, 4. Square root of so the vertical distance is 2, and the horizontal distance is 2. Is that right? I should put the coordinates here, right? This one is 6, 6, and this one is, oh, that's funny. It comes out greenish on there, huh? This one is 5, 4. That's a 5. Perfectly formed 5, I may say. And so this is 3, 6, right? And so this distance is, yeah, square root of 4 plus 4, which is 8. And so that's going to be a little less than 3. 2 times the square root of 2, so that's about 2.8. So why couldn't it be at 3, 5? That's a smaller y coordinate. Well, if it were at 3, 5, and the x can't be smaller than 3, so we get that out of the way. If x were smaller than 3, then you would fall off the roof. Let's just leave it at that. I mean, it seems intuitively obvious, doesn't it? So, oh, I need to get the chat window. Okay. And okay. So why is 3, 5 no good? That would be a smaller y coordinate with the same x coordinate, right? Well, at 3, 5, the distance to 6, 6 would be, what, 9 plus 1, the square root of 10, which is bigger than 3, so you'd be falling off the left side, right? Okay, that kind of makes sense. Shall we look at the other one? Am I here? What's happening? I'm trying to undo, but apparently I'm not. Can I get an eraser? Where's my eraser? Yeah, the GIMP toolbox. I can never quite. Is that the eraser? Yeah. And I want to make the eraser tool somewhat larger. Okay, but that doesn't erase to green. I see. That's a problem, huh? Oh. Okay. Okay, well, I can just undo. I thought that I was trying to do that before. Okay, and so what was the other one? Okay, so the other input here was okay, so we had 2 hatches. Okay, so yeah. Right. So the next one was 22. So 20 by 20 window with 2 hatches, one at 1, 1 and one at 19, 19. Well, that seems pretty obvious. Oh, that's a poodle. Poodle. So why is that? Let's go back to our drawing. I'll try to get back to my pencil, my brush, I guess. And the brush now has size too big. Okay. So now let's say this is 20 here. And 20 here, right? So it's a 20 by 20. So the hatches are going to be here and here. And so if you're going to have something that's going to reach both of those, it's going to, I mean, the smallest you could do is put it at the midpoint, which would be 5, 5. But then clearly the circle of radius, whatever, what, 5, oh, sorry, that'd be 10, 10, right? In the middle here. This would be 10, 10. And so this distance here to 19, oh, let's undo that. I should have a line tool, right? I'm fairly bad at drawing. Not very proficient with GIMP either. Okay, so let's imagine that's a straight line to 1919. This is 1919 here, right? It's the same distance to 1, 1, right? Which is going to be the square of 9 plus the square of 9. That's 9 times the square root of 2. Square root of 2 is about 1.4. 14 times 9 is 126, so this would be 12.6 roughly, right? But the idea is that it's going to be too big, right? It's going to go off the top. So that's a poodle, okay? And I'm going to undo all of these guys here. All right. Oh, can I redo? Yeah. Oh, no. Undo. Okay. And then what's our next input here? Okay, so this, whoops, 10-3. That means a 10 by 10 grid with 3 hatches, and at 1, 1, 1, 2, and 1, 3. Okay, let's go to the drawing board and say we've got one at 1, 1. That's going to be here. We've got one at 1, 2. That's going to be here. And we've got one at 1, 3. That's here. And pretty clearly, you know, a circle of radius 1. That's a perfect circle, by the way, of radius 1. We'll get to the edge of the roof, we'll get to both hatches, and there's sort of a unique point that will do that in that case, right? Okay, let's go back to, what am I looking at here? I should be looking at the code window here, okay, and so I'm going to turn off the paint window, and let's just delete that and say, all right, well, let's get the usual suspects rounded up here. What do we need? Do we need a vector? Yeah, maybe. Even if we don't need it, we should try to use it, right? Because part of this is to, you know, use our tools. And in fact, let's make something called a point, right? And this is sort of a classic thing, right? And a point is going to have integer coordinates. So yeah, I think we can only have integer coordinates, right? So we'll have these two xy coordinates, and we'll have a constructor, right? So those are private data members, and we'll have something called point, which takes an input for x and an input for y, and in the instantiation list, initialization list, yeah, that's we're gonna say x is going to be x in, and y is going to be y in. We'll have an empty body here, and maybe we should have some default values for these. That way we get our default constructor without making a separate one. And we need to get x and get y. So get x. So this will be a return x, and get y will return, whoops, what's going on here? Oh, that's the end of the return y, and what else do we need? Well, it might be nice to have the distance to another point, right? So and that's going to return a double. So we're going to have to do, will it be an implicit cast? Potentially. So the distance, and that's going to take then another point by, let's say, reference. Should we call it other? I don't know what. And this is going. Oh, so we're going to need. Well, do you need the? It doesn't hurt to include it. The CMath library. Could be we need it for the square root, but I think square root has gotten sort of elevated to. Yeah, who needs a math library for that? So we're going to return the square root of what? My x. Oh, and do we have to cast this as a double? A couple. I think we can get by with a single one. So other dot get x. And I guess we need to multiply that by itself. I know there are those amongst ye who would like to use the I'm wondering why is that underscored. Could be it just doesn't know what it's doing, right? Plus, and so I think, okay, so I'm going to say y minus other dot get y, I guess times y minus other. I should have my I on the, okay, dot get y. Other is not happy. Do we need another parenthesis? Yeah. I was thinking maybe other would be happy if I just arrowed down here. Okay, so other is an object of type a constant reference to point, or a reference to a constant point, I think is the way to say that. And well, what does it say if I hover over it? The object has type qualifiers that are not compatible with the member function getX. I don't know what you're talking about. What you talking about? All right, well, we'll maybe see. Let's try. Okay, so what are we going to do? We're going to have a function called main, where we're going to declare what do we need? S, which I think is the side of the square. H, which is the number of hatches, and then we're going to have a vector of points, which are going to be the I think, yeah. So then a vector of point objects, which are going to be the hatches. All right. And we're going to read those in, right? So currently it's an empty vector. Why doesn't it like vector? Oh, I haven't included, yeah. If you don't see something, don't say something. I think that's, using namespace standard. Is that, okay. That fixed this line, but I think we also need the number of test cases, right? So I guess we'll cin n and say while n post decrement. The usual sort of Kattis setup for getting test cases, right? And so okay, we then want to get these S's and H's, right? So input, should we go back up here? So in the first line is a single positive integer n. Each case starts with one line with two integers, S and H, where S is even. Oh, that's interesting. So you can't have a square with an odd side? I wonder why. Huh. And H is a number between 1 and 50. Okay, and then you're going to get the... Okay. So I'm thinking, let's figure out why this distance isn't working. Because anybody? Yeah. Why? It says, well, you don't see the dialog box, but if you hover over this thing, it says, the object has type qualifiers that are not compatible with the member function getX. Oh, so as usual, I'm nonplussed by that. Okay, and so I'm going to say cin, what is it, S and H, and then while H decrement, right, because this is going to be a bunch of, right, so we're going to get the X and Y coordinates. I guess we're going to need X and Y, huh? And so we're going to say down here cin X and Y, and then we're going to construct a point with those and add it to our vector of hatches. So we're going to say hatches.pushback a point constructed with X and Y. Okay. So now I'm starting to think I didn't demonstrate good design practice here, did I? The idea being to think it through before you start slapping code up on the wall. And I'm thinking, you can never have a leash at 0, 0, right? So you start with 1, 1. Will a leash centered at 1, 1? I mean, this is the brute force exhaustive approach. There may be a more elegant, so I didn't talk that through, right? So one approach would be to start with the smallest possible XY pair, which I believe you can't have the leash attached to the edge of the roof, right? That just would never do. It'd be raining dogs. So start with 1, 1. Could you have a leaf centered at 1, 1? Well, if there's only one hatch, say at 2, 2, or at 1, 1, that would work, right? Or at 1, 2, or at 2, 0. Well, you can't have it. 1, 2, or 2, 1, right? So sure. So, and then as soon as you would then just by brute force say, well, would it work at 1, 1? If not, we want the smallest x coordinate first, right? So we'd go, does it work at 1, 2? Does it work at 1, 3? And at some point we may be able to abandon the brute force thing if what? I don't know. So a more elegant approach might be to find um, the average x value of all the hatches and the average y value of all the hatches. Start with something there and work your way out. I'm gonna start with brute force, um, and then maybe improve on it. Right. So. Um, when I'm done with this little while loop, I'll have loaded up all the hatches, right? Shall I make a comment to that effect? Load in the hatches. Okay. And then how about brute force? Search for smallest x, smallest y to anchor leash. Okay, so for int x equals 1, x less than s minus 1, or strictly less than s, I think, right? Because again, if x were equal to s, then we'd be at the edge of the roof, right? If you see something more elegant, you know, brute force is my go-to method. Arr! So for int y equals 1, yeah, y less than s. Oh, I guess I want to increment x. Oh, can I use x here? Maybe I can't, huh? So let's go with I. Why not use x? Well, I think x is already declared to be a variable of type int up above there, right? So we'll just use I and j. I think that'll be fine. And so what's our test case? Well, if the distance to all... so we want to find the maximum distance to a hatch, right? Let's make that a function, shall we? And I guess it'll return a double. And max hatch distance. And it's going to take a vector of points. Still kind of bothered by that function up there. Why isn't the distance working? So hatches, I don't know. And then we'll have a point, right? And so should we say the max is 0 and then just keep adding to that? So double max, I think that'll make it 0. Isn't that the default value for a double? Then we will say for every point P in hatches, if oh, we can't use P. Let's use H. If P dot distance to H is greater than max, then max equals p dot distance to h. I don't know. Is that, seems like I'm computing that distance twice when I could maybe just get by with computing it once. Here. All right. So then what? Return max? That may work or not. So down here, we're doing brute force search, right? And we want to say for every integer coordinate starting at the lower left on the interior, 1, 1, right? If the max distance to a hatch doesn't take us off the edge, right? So we want to test if max hatch distance from hatches to, I think I can just construct a point with ij, right? And so we want to say that that is not off the edge, so it's got to be less than I. Now it's a double and we're comparing with an int, but that shouldn't be a problem. But why is it complaining here? I probably have oh yeah, extra parenthesis. Yeah. Okay, so it's happy with that. So I want that to be true, but I also want it to be, so that's not falling off the left side, right? I also don't want it to fall off the bottom. So I don't want to keep computing this thing, right? So let's make a variable max hatch, I don't know, and call it this thing here. So we just compute this once. And so I'm going to say if that is less than I, and I think it's got to be all of these things, right? So it can't fall off the left side. It can't fall off the bottom. Do we have to worry about that? Sure. So max hatch it's got to be less than j, right? So then it's not falling off the bottom, and it can't fall off the right side. And the right side is going to be s minus I. So it should be less than s minus I. And it can't fall off the top. Minus j. If all of those things are true, then we're going to print out, then we found our answer, right? Through brute force. Hearing no complaints. So I'm going to see out, what do they want? They just want the should we go up here? Yeah, they just want sample output. There's a typical like X and Y, right? With the X and Y coordinates where you're going to attach the leash, right? So we're going to say, oh, well, I space J inline. Do we want to then break out of here? Yeah, how do we get out of this loop? Because we're done searching. We don't want to search anymore once we found it, right? Oh gosh, we're an hour in already, huh? These damn problems take too long. But if they don't have to be correct, you can just do them right away. Boom. 0, 0. That's the answer. Done. Let's see. I think we say break. Will that break out of the whole thing or just break out of the inner for loop? So I guess one way to handle this is to say, have a little boolean, which is, have you found it? If you have found it, then what if we could just return at this stage? No, you can't return two numbers, so we want to print out the two. Could we just say return? Return as in return from main, right? So if this is true, I guess we. Oh, where am I? In a balloon. Okay, so this is too many ands on the same line. Oh, shall I do it like this? Okay, so I'm going to say return, just return, huh? Oh, well, I don't want to return from main because I still have to go, so I need to break out of the for loop. Can I just say break here? I'm not sure. Actually, I don't know if that'll break me out of just one for loop, or I want to get out of both of them, right? Well, I think maybe it's time to run this to see why is this happening, right? I mean, we've got problems here with this square root return thing. Why? So other is the parameter being passed into this distance function, which is a reference to a constant point. Is it the constness that's the problem here? Oh, yeah. So, yeah. So if I make the function const, can I pull it off that way? No, it doesn't like that, huh? Oh, it's sorry, it's not returning. Yeah, I want to do that in here, right? Nope. So we're promising not to change the point that's being passed in. And now we're not going to change anything, right? We're just computing something. And so we're going to return a double. We're not going to change other. And so this is sort of promising not to do that. And yet we're getting the same. The object has type qualifiers that are not compatible with the member function get. Oh, get, right. So we need to make get. Get is not changing anything, right? So it's also a const. Okay. Yeah, all right. So we took care of that problem. Right, and that's good practice to be sure that if you're not going to change something, then you should promise not to change something. All right. So, are we ready to try some input here? So here's we're gonna have some input. So, I guess, yeah. All right. So I'm going to attempt to compile and run. The compiler is successful. I go to the output window here so you can see that. All right. And I'm going to paste that in. And what? I'm confused. Am I? So I'm supposed to get 3.6 as my output here, right? I don't see a 3.6. So the input was 10.2, which is, 10 by 10 square with 2 hatches at 6.6 and 5.4. And it's coming back with 4.4 when it should be 3.6. So how come it didn't come back with 3.6? And then what is this? 5.4 is the next set of inputs. Okay, so this is saying oh yeah, no. Oh, so why is it? Yeah. So these are all being output. Yeah, because it's not breaking where it should break, right? Yeah. Sorry, I see a comment here from. Is that line I equals 5 then break? L equals 5 then break? Sorry, I'm not quite getting it. That seems like a good comment, Dave. Yeah, but it's clearly that we got a problem with the break, but we're making some progress. So let's go back to the code window and see. Okay, how do you break out of a double for loop? Well, we can go. Let's research that issue because it's obviously. Yeah. So if we're and why didn't it go to 3.6, right? Because we should have gone I is 3. All right, so let's suppose that we. Yeah, good thought. Okay, so let's take this whole thing here, cut it, make a function called it's going to return a point, right? Find leash anchor. That's not a terrible name. And it's going to take an integer s, which is the side of the square. It's going to take is that all? Oh no, it's going to need the vector of points, which are where the hatches are, right? And it's not going to change that, so potentially that should be a constant. Oh, all right. I guess we want to indent this. And then, so at this stage, we're going to return. So if we find it, then we don't want to print it out. We want to return, return the point constructed from I and j. That was a good suggestion. Okay, and that sort of follows our model of divide and conquer, or the design principle of divide and conquer, and that a function shouldn't try to do more than one thing, and our main function is probably already violating that, but yeah. Okay, so we're going to have a point called leash anchor, and have that be the output of find leash anchor with S and hatches. Now I'm a little concerned about the hatches. I think we have to clear them out every time we get a new n, right? So one way to do that is actually to move this declaration. I used to sort of like shy away from this sort of thing, which is I'm actually redeclaring this vector of points. But I think compilers optimize this, and so it's not like I'm creating a fresh one in addition to the old one, right? I'm actually writing over it, right? And so I have now a brand new hatches, which is empty. Or I could say hatches.clear, right? But I think this does that in a more elegant way, even though it seems like, why are you redeclaring this thing? I suppose we could find some discussion of that somewhere, but let's, for the sake of brevity, is it too late for brevity? Okay, so now we're going to see out leash. Am I misspelling leash? I think that's the correct spelling of leash. Leash anchor dot get x followed by a space followed by a leash anchor. Dot get y and a new line. Okay, let's give that a whirl. Do I have my I'm going to grab this input here. Whoops. I think we can just do it like that. Okay, and then let's go to the output window. Paste it in, and I see 4.4 again, right? So that's incorrect. Why is it not getting 3.6, or is it getting 3.6 and then moving on to get the other one? But notice now that it's not. Yeah, so we did solve that problem of, you know, breaking out of the nested for loop, right? Because we're just returning from that function. A brilliant solution. And 22 then with these there and there. This should say poodle, right? And we haven't talked about, but we're getting 4.4 again. Yeah, 4.4. That's always, the answer is always 4.4. And then, so this is the 10.3. 111. So 22, is that the correct answer for that one? Yeah, 22, that's correct, right? All right, so we're getting the last one is correct, but we're not getting the poodle, and we're getting 4-4, which I think kind of works. Shall we, let's go back to the drawing board on that. So I'm going to turn this on, and okay, so we have 6, 6, right, which was this point here, and we have 5, 4, which is this point here, and if we go 3, well, if we go 1, 1, obviously that doesn't work, so this whole column of ones is never going to work, right? And there's probably some way of determining, but then we go 2, and that whole column of 2's is never going to work. We go 3, 3, 1 doesn't work, 3, 2 clearly doesn't work, 3, 3, the max distance is going to be too long again, 3, 4, 3, 5, we saw that that almost works, but then 3, 6, right? That should work, right? And the way we're stepping through this for loop, so this distance is 3, and this distance is 2.8. Oh, I think, yeah, I see, I need to say or equal to, right? Yeah, because, yeah, so if it has to be strictly less than 3, then that's not going to work because it's exactly equal to 3. So let's fix that. Okay, so I need to close this output window. And what, stop the program? Oh, I guess it was already stopped. Okay, good enough. Let's get rid of that paint window. And oh, why is everything green underlined here? Because arithmetic overflow using the subtraction operator with blah blah blah. I don't think that's an issue, but okay. So where is that? Less than or equal. Less than or equal. Less than or equal. And less than or equal. Now, how do we handle the poodle? The poodle is not biting. There is no poodle. Okay, so if we get to here, then we're never going to return anything, right? So it seems like it ought to complain about never returning something. So in that case of the 20 by 20 roof with 1, 1 and 19, 19, it's never going to get to a point where all these conditions are met, right? And so it's never going to return, and so it should complain about that. But let's say we're just doing brute force here, right? So I'm going to say return point s. That's just sort of a flag, or I put 0, 0. Would that be a more obvious flag? So down here, I'm going to say if leash anchor dot get x is 0, then cout poodle. Otherwise, cout that. I think this may work. All right. Oh, leech. That's a blood-sucking animal rather than a limiting animal limiter. Okay. Okay, so I'm going to compile this. I don't know if I still have the input in my... So I'm going to go get this input here. Is this... Okay. I think that's all of it there. Yeah. And let's go to the output window. And we see... Now we got 3.6. Hooray! And we got Poodle. Hooray! And 1.2? It's supposed to be 2.2. 1.2. Well, let's look at that situation there. So if it's 10 and 3 hatches, wait, 1, 1, 1, 2, and 1, 3, then well, let's go to the drawing board, shall we? Where's the drawing board? Oh, I don't have it in the output window. So let's, I will make a note of my results here and paste that in where, how about up here? Current output is this, and for some reason I'm getting this 1.2 here, which I don't like. And so let's see, if I go to my paint window, I can maybe start to understand why I'm getting that. Okay, so I've got a 10 by 10 rooftop with hatches at 1, 1, 1, 2, and 1, 3. So it seems like 1, 2 ought to do the job. Why not, right? 1, 2, you're going to have a circle of radius 1. It's going to be your maximum distance to a hatch, and I don't know, why do I think that's wrong? Oh, because here they're saying it's 2, 2. One, 2 does the job and has a smaller x coordinate. What am I missing? Well, is there something about 1, 2 that isn't a better solution than 2, 2? 2, 2 is like over here, right? And that has a large, I mean, I suppose that would, I mean, if you're at 2, 2, then your distance, your maximum distance is square root of 2, which is 1.4. And so you're going to have a circle like this, which, you know, admittedly doesn't go to the edge of the roof like this one does. But it's okay to go to the edge of the roof, and you want the solution with the smallest x coordinate. So you're saying there's something in the statement of the problem which prohibits that. At which to fasten the leash. I'll put the one with the smallest x, so 1, 2 would be preferable to 2, 2. There are still several possibilities. Select the one with the smallest y. And they're saying 2, 2. Maybe they're just wrong. Or did I miscopy that? Our result is 1, 2. Oh, wait, is that right? Oh, yeah. Hold on. Yes, you're right. Absolutely right. Okay. Thank you. um, so, yeah, that's quite true. So, how do we fix that? We need to say, um, I guess, another condition here, right? Do we make that in here? Um, and maybe have a little Boolean function to handle that. A little Boolean function that says, am I one of the hatch points? Okay, so let's just do that. Okay, so I'm going to say typical Boolean function is like a is in, and it's going to take a point P and a vector of points VP, and for every point PT in VP. Oh, should we overload the comparison operator? That's probably a good thing to do here, right? So let's do that. So I got a Boolean function. I'm going to say operator comparison, and I'm going to say, again, I'm not changing anything, right? So I want to maybe say constant point other. So this will then return, return x equals other dot x and y equals other. Oh, I think we have to say dot get x, right? Because it's a private data member and we have a getter for that. So dot get y. Okay. So then this is in here. We're going to say if PT equals P, then return true, right? Okay. So then here we'll say one more condition, right? Which is that point and not is in hatches. I think the first parameter is the point, right? So point I j hatches. Doesn't like that. Is in takes a point and a vector of points. Oh, is that all? Okay. Oh, we also need a comma or an ampersand here. All right. Yeah, there's a lot of conditions. But I don't know if they're all necessary even, but okay. Run this and grab our input, which is here. Control C, go to the output window and drop it in there. Now we're getting 2.2. I think we're ready to submit. We got our 3.6 here. We got our poodle here. We got our 2.2 there. It's a poodle with a 2.2. Okay. And go to the browser. We've got then, I've got to, I guess, open the directory where this is at. Open file folder. And so this is Kattis, Watchdog. Okay, and then I've got our thing here. I'm going to say submit because resistance is futile, and drag in my Watchdog. I don't know. Submit. Testing, thinking, waiting, compiling. It doesn't pass the first test. Oh. Is in oh. Control reaches end of non-void function. Yeah, it's giving me. Yeah. So yeah, right. So we if you're going to return a bool, it's funny that our compiler's not complaining about this. Some compilers will complain about this, and clearly Kattis is using probably GNU, and we're using Microsoft. So. Yeah, so I think we just need to say return false here. Right. Oh, sorry, where? Right there, and that is in function. So actually, Kattis was complaining about line 113, and they actually gave us a line number, which is nice. And so they're saying, yeah, you need to do this thing here. So if I save this, I'm not even going to compile it again, because... so what do I have to do here? Go back, or let's see, I'm in the browser again, and can I submit again? Drag and drop. Does it say? So it does. Yeah, right. Whoops. Okay, so I'm going to submit Watchdog. And go to here and drag it in again and submit, and it's thinking about it. Oh, accepted. That's nice. That's a whole 2 points too. We haven't done a 2-pointer before. Was it worth 2 points? I guess it's all relative, like my Aunt B. Anyway, all right. I guess we're done with that. Any comments about that? Did we learn anything? Was it? Yeah, it would have been worth it if we learned something. Well, yeah. I mean, it was. We practiced our design principles. Notice our main function is fairly short, and uses nice container, a vector of points. So we built a point object. Was that useful here? I think so. Yeah, whenever you're dealing with a coordinate system, it's nice to have. You'd think that this would be sort of a built-in object, and in the standard template library, we do have something called a tuple, which is essentially what this is. Should we look at the tuple? Let's go to the browser and ask about C++ tuple versus point. So versus struct, okay. With, yeah, I mean a point is so simple that it might as well just be a struct, right? So this person said, is there any difference between using a standard tuple and a data-only struct? And so here he's got type definition, tuple of, and we'd have just int, right? A tuple of ints. I'm not sure what member functions are bound up with this standard object tuple, but bar t. I'm not sure what bar type or something, and so it's got an int, a double, and a bool. Whether the bar is dirty or not, I don't know. From what I found online, I found that there are two major differences. The struct is more readable, while the tuple has many generic functions that can be used. Should there be any significant performance difference? Also, is the data layout compatible with each other? And there's 11 answers here. This person gets 25 upvotes with a fairly long response. That's pretty long. This guy gets 24 with a somewhat shorter response. Let's look at the first one a little bit here. We have a similar discussion about tuple and struct. And I write some simple benchmarks with the help of one of my colleague. Those darn ESL people. No, I welcome all our ESL brethren and sistren. From one of my colleagues to identify the differences in terms of performance between tuple and struct. We first start with a default struct and tuple. All right. We then use Celero to compare the performance of our simple struct and tuple. Below is a benchmark code and the performance results using GNU and Clang. Yeah, so interesting comparison thing that he's performing here. Can I pull this down actually a little bit further? Yeah. So we have a vector of struct data. Yeah, well, maybe this is getting further. This Celero, I don't know. I haven't used that. Here's Celero main. So it has a baseline and a benchmark. That might be something to look into. And the timer resolution is a thousandths of a microsecond. Is that? I think that's a microsecond there. And so there's Clang, and here's GNU. We can clearly see that tuple is faster than a default struct. Oh, I don't see that here. What am I missing? Oh, maybe it's... Oh, yeah, see, there's all this information over here. I didn't see all that. So which one is which? The struct and then the tuple. Okay. So the tuple is a little shorter thing there. A little microseconds per iteration is a little better there. Iterations per second, a little more. That's good, right? That's better. I mean, we're using brute force, and so we could get much better optimization, by considering a more elegant solution. Because what if the solution is in the upper right corner and we're starting at the lower left corner? It might be better to find the average x coordinate, average y coordinate, and then look at the taxicab distances on the grid. That is, you have to get the average x and the average y will not necessarily be integers, right? So, you'd look at the integer coordinate neighbors of that average. I'm thinking that's probably, because you're looking for the center, right? And is there a center that will keep our dog on the roof, right? Um, so we could probably spend the rest of the morning finding a better algorithm here, or dicing over the differences in tuple versus. But yeah, it looks like there is some improvement to be obtained using tuples maybe as optimization. And so if you're using several, here's the second answer. Using several different tuples in your code, you can get away without condensing the number of functors. What's a functor? You are using. I'm going to look up functor in my Funkin' Wagnall. I think it's probably not a general. Oh yeah, there is something. It's in logic. It's a function or operator. It's also in linguistics. And you can have a functorial. Come on. Yeah. So I think you could just sort of think function or operator. I say this because I've often used the following forms of functors. So here's a tupeleless structure that has a template. So it's a template operator. So he's overloading the parenthesis operator. Oh, I guess maybe that's what makes it a functor, right? Because you're taking a parameter list essentially in parentheses. And he's defining boost. Oh, tuples element. Yeah, this is beyond our ken, right? This might seem like overkill, but for each place within the struct, I'd have to make a whole new functor object using a struct. But for a tuple, I just change n. Better than that, I can do this for every single tuple as opposed to creating a whole new functor for each struct and for each member variable. All right, I guess, for us, we might just look at this and say, yeah, if we'd used the existing tuple object, then we wouldn't have had to build all this stuff, right? Because it's probably embedded in the tuple. So shall we look up tuple? What's the tuple API? So C++ tuple, and there's a C++ reference. So what are the member functions? So you can swap, you can get element. Oh, you're not look. Sorry, yeah. What am I? I'm looking at the browser. I'm looking at the C++.com, and they've got a little reference on this template class called tuple. And we haven't really talked about templates, so that's a bit beyond where we are. It's just like it sounds. It's like a cutout, right? So in any case, the assignment operator is overloaded. The swap function is defined. The get non-member function overloads. Relational operators. So I think, yeah, so we wouldn't have had to overload the comparison operators, perhaps. And you see an example of, here we have a pair. So what's the difference between a tuple and a pair? Well, pair is a member of the map library, and it is largely bound up with that library, whereas a tuple is, I think, more independent. Oh, look, it's a whole library unto itself, right? And yeah, so make tuple, yeah, and so this is for an int and a character. There are 4 parameters for make tuple. I'm a little surprised by that. We'd have to get into the weeds here a little bit further, but yeah, let's leave it at that. If there are no further questions about that, I think what we'll do is go back to the yeah. I see. Yeah, you're right. Yeah, I was getting good advice in the comments. All right. So I guess we'll go to here and say, yeah, we did our Kattis warm up, and it's now 10:47. All right, so a little Stroustrup. So I think I have to open up my Sumatra PDF reader and get Stroustrup there. All right, and we're on chapter 6. I think we kind of worked through all the exercises there, didn't we? Yeah, yeah, even the permutations and stuff, right? So I think had we started on chapter 7? Let's get started in there. Oh, I need to bring up the where is it? Stroustrup? Is that? Yeah, there it is. Okay. Let's just break the ice in here, and then we'll take a break. Break and break. All right. Couldn't this be a vector of pairs? Is the question I'm getting. Yeah. A vector of pairs. Well, I think in order to, well, since you raised that issue, let's say we want to compare a tuple. Oh, I want to go out here and say compare a tuple with a pair. Tuple versus pair? I don't know. Difference between standard pair and standard tuple. I think that's another good question, huh? With only 2 members. Right, a tuple actually can have more than 2. Two makes it sound like 2, but it's actually multiple tuple. I should pronounce it tuple rather than tuple, so as not to prejudice the issue. So is there a difference between standard pair and standard tuple with only 2 members, besides the obvious that pair requires 2 and only 2 members, and tuple may be more or less? All right. 5 answers. This has 85 upvotes. There are some differences. Tuple can never be by standard layout. I'm not sure what he means by that. At least it's not required to be by the standard. I think we're missing a verb here, right? Every pair is standard layout if both T and Y are standard layout. So yeah, T and Y being these type names. It's a bit easier to get the contents of a pair than a tuple. You could have to use a function call in the tuple case, while the pair is just a member field, first and second. That's about it. Right, so first and second for a pair, whereas with a tuple, maybe it's not quite so direct. This is a very late answer, with only 26 upvotes. But note that because pair is defined with member variables, its size cannot be optimized using empty base class optimization. Oh yeah. First and second must occupy distinct addresses, even if one or both is an empty class. This is exacerbated by whatever alignment requirements the second type has. So in the worst case, the resulting pair will be basically twice the size it needs to be. Tuple only allows access through helper functions, so it's possible for it to derive from either type if one or the other is empty. Huh. All right. Well, it's another invitation down the rabbit hole into Solero testing and benchmarking and what's optimal. And sometimes the compiler says, oh, you're using a pair when you should be using a tuple or vice versa. I'm just going to fix that for you, stupid programmer man. Um, I kind of doubt compilers optimized to that extent, but they're getting more and more involved in that sort of decision making. In any case, I think I went to the wrong place here. Okay, so we're back to there, and we want to go to here. All right. So, yeah, I think we talked through this part here, the error handling. First thing to do once you have a program that basically works, oh, well, maybe we need to bring up something that basically works. And which one would that be? Okay, I'm going to go to the code window and exclude from project. Okay, and then add existing item. And I don't know, we got calculator. There's one from April 5th. I think we wanted something a little bit nice. So we want like PPP 6 point something maybe. Is it this one? So that's April 13th. Yeah, I think maybe that's a pretty good calculator. I think maybe chapter 7 code will bring in some pretty good calculators too. So let's go ahead and open this one and see what that has for us. Is this the one with the factorial? Yeah. Okay. So back to Stroustrup. Try to break it. Try to feed in. Okay, so what happens if we enter in? So let's test each one of these guys here, right? In fact, this is the try this. Feed a few such problematic expressions to the calculator and try to figure out how many ways you can get it to misbehave. Okay. Well, I don't know. I don't see why that should be a problem. 1 plus 2 plus up to 8, so it's going to be, 36, I think. So I copy that onto the clipboard. I go to our code. I compile and run. I go to the output window, and I paste that in with a semicolon and bad token. I broke it. Consider it successful. Why did that break it? I don't know. I better test this some more, huh? So what if I just go 1 plus 2? That's 3. 1 plus 2 plus 3. That's 6. 1 plus 2 plus 3. Oops. Plus 4. That's good. Maybe it just was a bad character. 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8. I think that's what we had, right? And that should be, oh, bad token. Huh. So what stage does it become bad? Huh. And how would we trap that error? I hadn't expected that. All right. So we got up to 1 plus 2 up to 4. So I'm going to go up to 5. That's okay. Up to 6. That's good. These are the triangular numbers, right? Up to 7. How does Stroustrup know that this would? That's good. Bad token. Is it the 8? You know, 8 is the character for. Okay. All right. Um, the 8. Yeah, bad token. So what if we just put in 8? 8 plus 8. Or 8 plus 1. Yeah. Okay, so we got to go figure out where is it that it won't take an 8. All right, so back to the code. All right, that gives us a chance to review the code. So is that the get? So it's constructing. Okay. Oh yeah, we just. Oh, goddamn devious Stroustrup. He just left out the. He left out that case. That was one of the bugs we were supposed to catch and never did. I don't know how we got by with that. Okay, there it is. Okay, so now that's 36. Well, I think that little feat of amazing debugging deserves a break. So, any questions about anything before we take a break? Pairs are simpler, is the comment I'm seeing here. Yeah. Yeah, there's a lot of comparison to do there. Okay, I'm going to go back to the code. Well, we got the code window here. Okay. All right, so let's take 10 and we'll get into the calculator debugging, finishing sort of thing. I'm going to pause the here and there as well. All right. So I was just perusing the latest edition of College Math Journal. I think it was. Was it the College Math Journal? Which has a slippery duck theorem, which involves a pursuit curve, which is something I've done before in this class. Or there's variations on it. So I suppose we can get to that. But I suppose if we were going to, I was muted, wasn't I? Sorry about that. Yeah, I was talking about the slippery duck theorem. Okay. The slippery duck theorem, which is a pursuit curve and is written up in the current College Math Journal as an interesting problem. And I was mentioning how I have done pursuit curves like that in this class. It's kind of an interesting simulation of paths that are taken in pursuit. All right. In any case, we're back to here, and we're gonna, so should we try some more of these? I don't think this is going to be a problem. But let's test it. So I'm going to go to the code, which is here, and compile and run it, and that takes us to the output window. And I see this, and what should we get? Well, this left to right, right? So you get -8, I believe. All right, looks good. I'm just going to read them off the, so then I have the factorial of +2. Now, how should that parse? The factorial primary expected. So should that make sense? If not, why not? Okay, so I'm going to say, oh, yeah, of course you wouldn't have a factorial before. Of course not. Right, so we could have +2 factorial. That would be okay, but we wouldn't want factorial to be parsed as a first character, right? Factorial operates on whatever precedes it, right? If there's nothing there, that should not parse. How about just 3 semicolons? He's got that here. Primary expected. I thought I thought the semicolons would eat each other, and then that would be the end of it. So what's happening if we're getting... Okay, I'm going to go to the code window. Can we follow the path of destruction for semicolons, right? So here's our entry point. We declare a variable type double called val. While cin is in a good state, we call the token getter. And if it's a semicolon, then we're going to print out the val. But val is 0. Right, because it's initialized here to 0. So it should say equals 0 for the first semicolon, and then he gets another semicolon. Yeah, that's not quite behaving properly, is it? I think we want to sort of rethink this. In fact, the last version we had just had main calling calculate, right? And calculate then doing all of this, right? Can we try that much? So I'm gonna make a spot here for calculate, which should return a double. And I don't think it takes any input, and it's just going to do all of this, huh? And then main is just going to call calculate. Is that, well, I don't know. Let's see if that even compiles now. Yeah, sure. And here's the output window. So if I now say 2 semicolon, that's just 2. How about 2 followed by 2 semicolons? The second semicolon causes a problem, right? Which it shouldn't. It should just eat those up, right? So why is it not eating up the semicolons? I think it's because we want to have a little while loop there, right? So we want to say while we get semicolons, keep eating them. All right. So let's make a note of that. There's something. How about an unmatched parenthesis like 1 plus 3 semicolon? Yeah, it expected but it crashes then, right? So we would like it to not crash in a case like that, right? And he's going to suggest a function called clean up mess. Okay, so feed a few such feed a few such problematic expressions into the calc and try to figure out in how many ways you can get it to misbehave. Well, are any more of these that are of interest? How about this one here? All right, let's go ahead and do that then. So I'm gonna do this and go back here and run that and get to the output window. And okay, so what should this be? Well, it doesn't like the modulus operator, right? And can we fix that? Well, I think we had it working at some point, didn't we? So it's going to be part of term, right? As it is, term doesn't handle that. In fact, I don't think we can build a modulus token, right? So here are various operator tokens, plus, minus, times, divided by, and factorial. Let's go ahead and add, oh, sorry. Go ahead and add modulus operator as a case. And so then in that case, we'll build an operator token from the modulus operator, and then we need to be able to handle that, which is going to be done in term, I believe. So, we don't have a quick address for term. All right. I thought maybe we could get to term quickly. Here's get. Here's expression primary. Here's term. Okay, so in the case of that the kind of operator is a modulus operator, then we want to say, I guess in curly braces here, now, so here's the deal. We're dealing with doubles, right? And what's the analogy for, division? I think what we can do is keep modulus. So what's the analogy of a remainder after division by a floating point number, right? And I think what we'll do is just keep subtracting the divisor from the dividend until we get something less than the divisor and return that. Okay, does that make sense? So I'm going to say while okay, so we've got, I guess we want to get the next, we want to get the next primary, right? So I'm going to say double, then that'll be the divisor, right? Equals primary, the output of the primary function. So I'm going to say then while, what have we got? Left? I think left is, left is the dividend. So while, do we want to make a copy of the dividend? Yeah, so let's say dividend. I'm just going to use the proper terms here, right? I'm going to assign left to dividend. I'm going to say while divisor is less than dividend. Yeah, I know. I was sort of deliberately avoiding that. I think but I think that's kind of going to do what this is going to do what fmod does. But it's just like the square root function. We like to build it ourselves because who needs a standard library, and who needs even primitive types, right? Because we can do everything in assembly. And I think this is not too bad. So I'm just going to say while that's true, I'm going to subtract the divisor from this. So the dividend minus equals divisor. And then what I'm left with then is the so-called dividend is no longer the dividend, right? So we're not going to return at this stage. So we return left, right? Oh. Well, maybe I don't need to do this. Then I can just. What do I mean? I mean while, because we're going to destroy left, right? We're going to replace left with what it should be. So while divisor is less than left, left is going to be diminished by divisor. Okay. And then I think we'll want to get the next token. And so now there's a problem. What if the divisor is 0, right? And that will be an infinite loop. If divisor equals 0, CR we can call the error function, right? Just like we do above there. And that's the same problem, right? Divide by 0. Or division by 0, maybe, in proper English. And okay, so then that will work, and then we're going to want to say get the next token, and which will put back if it's not the well, we're going to put it back in either case, right? If we're done getting either multiply, divide, or modulus operators, then we're going to put back whatever we got and return what's left. All right. So that should work now, right? Famous last words. Here's the output. Whoop, that's the wrong window. So, oh yeah. I want, oh, well, let's see. Should we try 2.8 modulo 1.3, which should be 0.4 or 0.2, I mean, right? Yeah. That should give us a division by 0 message, right? And then we're also out of there, right? So that's kind of a crash, which we want to learn how to recover from that. But okay, so I mean, we built a little bit something beyond where we were, and how about 0? Why should that be a problem? It's just going to be 0. 1 plus without an operator, operand, I mean. I think that's poorly formed. Positive 1, I think, without a semicolon. Not sure what that's going to do. Oh, how about the increment operator? Do we want to be able to do that? Yeah. The post increment operator? We don't have that, right? So we'd have to say if we get the plus operator, then get another operator. And if it's the plus operator, then build an increment token, operator token, right? And I'm not going to worry about that now, but that's, yeah. So division by 0. If you have plus positive 2, that's not an increment, that's just adding positive 2. Negative, yeah, we handled that. How about a number that's too big? Or something that's not a number. Q, 1 plus Q, 1 plus 2Q. All right, let's say we tested pretty well. Okay, you know, he says try things like Mary had a little lamb, or you know, something you got in your email or something. In fact, I think that's his comment here. He had a habit of feeding email that reported compiler errors straight into the compiler. Little thought. Okay, so the first really annoying thing we noticed is that the window closes immediately after inputs such as this. Oh, actually, ours doesn't. Well, 0? Does that cause a problem? I don't think 0 is a problem. Oh, are we still running something here? Okay. So I'm going to go 0. Well, I mean, it needs a semicolon, right? And then it says that's 0. Yeah. But there are some cases where it does crash, huh? And he's going to talk about how to fix that here. We could deal with that by modifying main this way. What is our catch doing? We do have a catch, right? And it's saying unknown exception, or yeah, here. I think that's essentially what he's saying to do. Yeah. So then he says, example, so we already have this, right? And so examples such as +1, please enter squiggle squiggle to exit. Oh, so this is when we encounter this problem, we wrote keep window open that takes a string as its argument, blah, 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 blah. So a simpler solution is this one. Oh. So yeah, that's not a good solution, so let's just move on. So that makes testing tedious. Each time we make an improvement, we have to type in a lot of test cases yet again to make sure we haven't broken anything. It would be much better if we could store our test cases somewhere and run them with a single command. Some operating systems make it trivial to get cin to read from a file without modifying the program, and similarly to divert output to an output file. If that's not convenient, then we must use a program. We modify the program to use a file. That's in chapter 10, which we should do. Well, let's move on so we can get there. So now consider these two expressions. We would like both to print the result 3 and then exit the program. Curiously enough, this does that? Does it really? But the apparently cleaner elicits a primary expected error. Where would we look for that error? In main, where semicolon and q are handled, of course. We added those print and quit commands rather quickly to get the calculator to work. Now we are paying for that haste. Okay, so consider again. I think this is the code we're using for, I've got it here, so cout. Oh, wait, I don't have the prompt actually. Which, maybe I should add that, right? I'm going to type it in there. Yeah, so if t.kind equals q, then break. If t.kind equals semicolon, then print out the value. All right, so this is kind of where we're at, right? If we find a semicolon, we straight away proceed to call expression without checking for q. The first thing that expression does is call term, which calls primary, which finds q. The q isn't a primary, so we get our expected primary message. We could test for q after testing for a semicolon. While we were at it, we felt the need to simplify the logic a bit. So the complete main now reads like this, and I'm going to make this the body of calculate, right? Can I do that? So I'm going to copy this onto the clipboard and go to the code window and say, yeah, all of this is going to be replaced by that. So, oops. Okay. So this should all be outdented, right? Because we don't typically indent the try business. Is that right? I don't know. So while put out the prompt, get a token. If it's the so this is now going to eat semicolons, right? Rather than calling evaluate, we're just going to get the next token while it's equal to the semicolon token. All right, so now let's see if this works. Oh, it doesn't. Keep window open. Oh, right, that doesn't exist, right? Do we have can we call error on that or something? Yeah, let's just comment that out, huh? Will it work if we just comment that out? No. Oh, it's got another keep window open here. Okay. Okay, so now we have our prompt. If we put in 3 semicolons, nothing happens. Okay, so it's eating the semicolons, but it's not prompting again. That's not terrible behavior. It's better, right? Okay. And, oh, we don't want this here. So if we get a Q, we're going to now return from calculate to main, which is then going to end, right? Otherwise, we put the token back and call expression. And so there's something in the buffer. I guess we don't want that. Okay, well, I'm going to assume this is good and get back to over here. And negative numbers, we already handled that, right? So the remainder, we already handled that. So cleaning up the code. Oh, notice that he handles the modulus operator a little bit differently. He says, you know, do a narrow cast to an int of what's in left, and get the divisor. So that's I1 and I2. If I2 is 0, divide by 0. Otherwise, you've got 2 integers. So basically, you're just truncating your operands. I think our solution is a little bit more elegant. And as Jonathan suggested, that I think is equivalent to just calling fmod. Cleaning up the code. We have made several changes to the code. They are, we think, all improvements, but the code is beginning to look messy. Now is a good time to review the code to see if we can make it clearer and shorter and improve comments, etc. In other words, we are not finished until we have a suitable for someone else to take over maintenance. Except for the almost total absence of comments, the calculator code is not so bad. So let's do some cleanup. We find the use of 8 to indicate a token to be a little odd. It doesn't really matter what value you'd use. Indicate a number token. So and we had to put in this comment. To be honest, we also made a few mistakes typing to the character 0 rather than 8 because we forgot which value we had chosen. In other words, 8. Using 8, the character 8, directly in the code manipulating tokens. That was sloppy. Hard to remember and error prone. 8 is one of those magic constants we warned about in chapter 4. What we should have done was to introduce a symbolic name for the constant we use to represent a number. I think, did we already do this? If I go back to the code, do I have these characters? I did this in, I think, a different version, right? Yeah, I don't have any constants up here at all. Or I don't see any. Scrolling. Keep those cursors scrolling. Okay, so constant, actually I think, can we just copy and paste? He's got a bunch of these, right? Yeah, well, all right, well, let's copy and paste that then. Oh, I'm sorry, I'm copying and pasting from the book this, right, which includes the comment t.kind equals numbers means that it's a number token, and we're going to rename or have another name for this character, which is the word number. And so then down here where we're getting a token and we see that we got an 8, we can instead put the word number here, and that will mean the code reads more cleanly and we can get rid of this comment, right? And there are a bunch of other places where we can do things like that. Okay, so the case we get a number, I think we did that, right? So, oh, was there another place where we had, okay. So he's saying the get that recognizes numbers becomes this, put back character double value. Return, yeah, so when we're constructing, oh, that was right here, huh? Oh, where? There. I don't know, is there any other place where we see this special character 8? I don't think so. Okay. Yeah. All right, let's just move on then. We should consider symbolic names for all tokens, but that seems overkill. After all, parenthesis and plus are the most obvious as a notation for what they mean, right? Only the print for terminated expression. Okay, so let's go ahead and add these guys to our list of constants, our global constants. And those are scrolling here. Okay, and so when we see the quit token, that's going to be in main, right? Or no, in calculate. So if we get the quit token, now we can, that doesn't have to be a magic character. That can be a word that means what we want it to mean. And this same thing, right? Global constants for better expression of meaning. All right, and introducing symbolic names, right? Yeah, so now the prompt and the equals stand out. Okay. There's a lot of this sort of stuff you can do at this stage, right? So I'm going to go back here to the code, and I think I'm good if I just jump to the top this way. Oh, okay, this way. Okay, so those are constant strings, right? But now at the calculate here, I can say cout prompt, and cout, is this result? I think that's what he called it. Result. Yeah. Okay. Kind of trivial, but you know, you want your code to look good for other people to take over, and not curse you as they do so. Should we want to change the prompt for the result indicator, we can just maintain. Okay, so we did that. Okay, so use of functions. And yeah, so we've done some of this already. And he's suggesting, you know, main just call calculate, which does this. Ideally, a function performs a single logical action. Having main perform both the scaffolding and the calculation is then two things and obscures the structure of the program. The obvious solution is to make a calculation loop into a separate function. Okay, and we already did that. I think this is in fact our calculate here, right? Put out the prompt, get a token. If it's a print token, keep getting until you get something else. If it's the quit token, then return. If it's none of those, then put it back and call expression. Yeah. And then main is just going to, oh, main has its own try. So I put the try into calculate. Should I put the, yeah, maybe so that scaffolding maybe belongs more properly in main. Shall we do that? I know, I don't much like this sort of thing. Okay, so this is all the catch stuff here, which I'll put here, I guess. Which I guess I want to outdent. Alright. Should we test it? I mean, it could be we got an extra semicolon here now, or not enough semicolons down here. Is that right? No, I think we're good. Let's test it. No. No try block associated with okay, so main try. Okay, yeah, sorry, I am missing a semicolon there, and I guess I want to outdent that. Is that then good? Just calculate and then catch if something goes badly. He's got return 0 and keep window open, but those are both sort of superfluous, really. So let me see, does it compile now? Yeah. And, oh, that's the wrong window again. So let's see, what am I doing? I don't know what I'm doing. 42 factorial. Oh, I can't, oh, then semicolon, right? Okay. And that's a big number. Oh, good. Okay, back to Stroustrup. The code layout, yeah. Let's just skip over that section. Commenting, okay. We've got a few comments as we went along. Good comments, blah, blah, blah. When you go back to the code to clean it up, it's an excellent time to look at each part of the program to see if the comments you originally wrote are still valid. Yeah, this is something I'm guilty of. I just ignore the comments, and when I change the code, the comments just carry on in a meaningless fashion. Are they adequate, or are they too verbose? What is said best in code should be said in code. Avoid comments that explain the obvious, right? Yeah, the calculator should have like a revision history, okay, and together with the grammar. That's a good thing to put in there. Recovering from errors, like this is kind of important, and I didn't leave enough time for it. Shouldn't have wallowed around and all that other stuff. Why do we exit when we find an error? That seemed simple and obvious at the time, but why? Couldn't we just write an error message and carry on? After all, we often make little typing errors, and such an error doesn't mean that we have decided not to do a calculation. So let's try to recover from an error. That basically means that we have to catch exceptions and continue after we cleaned up any messes that were left behind. Till now, all errors have been represented by exceptions handled by main. If we want to recover from errors, then calculate must catch exceptions. We just moved that into main. Now we're going to move it back. Or can we have the try and catch in both places? Let's see if we can, right? So this is not for calculate, but for calculate's while cin loop, right? Try to clean up the mess before trying to evaluate the next expression. Okay. We simply made the while loops block into a try block that writes an error message and cleans up the mess. Once that's done, we carry on as always. Who's cleaning up the mess? Oh, clean up mess. Is that a known function? No. Okay, so let's go ahead and throw this catch block in there. It's not going to work because we haven't defined cleanup mess, right? So for while here, we're going to say try. I think actually it goes like here, right? Try and catch cleanup mess, right? So that function has not been defined. So let's go back to Stroustrup and see how he's going to define this. What would cleanup mess entail? Basically, getting ready to compute again after the error has been handled means making sure that all our data is in good and predictable state. And we could use an enumerated type called state, and go that way. That's not what he does here. In the calculator, the only data we keep outside an individual function is the token stream. So that what we need to do is to ensure that we don't have tokens related to the aborted calculation sitting around to confuse us for the next calculation. So, for example, this will cause an error. Actually, I don't think it will cause us an error. This will be left in the, yeah, because the double plus there would not parse according to the way he's doing it. Okay, so we want to purge all tokens from the token stream, purge all tokens from the current calculation from the token stream. Oh, those are our choices, right? The first choice discards all, including the 4 plus 5, whereas the second choice discards the 2 times 3, leaving the 4 plus 5 to be evaluated. Either could be a reasonable choice, and either could surprise the user. As it happens, both are about equally simple to implement. We chose the second because it simplifies testing. So here's our cleanup mess. And we're going to have to define it somewhere. Where? How about just before calculate here? So what is it doing? It's saying while infinite loop, keep getting tokens. If that's the print token, return. That doesn't seem to really clean up the mess, right? Because our token stream could be clogged up with something. Maybe not. All right, well, let's see what he says about this. We're running short on time. Unfortunately, that doesn't work. Why not? Well, consider this input. The ampersand gets us into a catch clause for the while loop. Then we call cleanup mess to find the next semicolon. Then cleanup mess calls get and reads the z. That gives another error because z is not a token. All right, and we find ourselves in main's catch again, and the program exits. Okay, so we don't get to evaluate 1 plus 3. So if you got 2 garbage characters in a row, it's not going to handle that exception. We could try more elaborate tries and catches, but basically we are heading into an even bigger mess. Errors are hard to handle, and errors during error handling are even worse than other errors. So let's try to devise some way to flush characters out of the token stream that couldn't possibly throw an exception. The only way of getting input from our calculator is get, and that can, as we have just discovered the hard way, throw an exception, so we need a new operation. The obvious place to put it is in token stream, and in token stream we're going to have ignore. Okay, so I'm going to copy and paste this into the token stream, which, can we get that here? No. I can go to the top. I think it's pretty early on. Yeah, here. So we've got put back, and we're going to add ignore. So discard characters up to and including a C. And what should C be? Well, C is going to be the print character. So we're going to keep getting tokens and ignoring them until we get a particular character, in particular the print characters. So I think we have to define this ignore function. Where do we do that? Down here? Yeah, this is, we define token stream here, we define put back here, and let's go ahead and define ignore here. So I think it's a void function. And it's in the context of token stream. in the scope of token screen, and so we're going to have ignore, and it's going to take a character C, right? And while oh, what does he do? If there's something in the buffer and it's equal to our print character, or C, then empty out the buffer and return. We're done, right? Okay, so we need to consider that case. So if full, right, and what something equals buffer dot kind, right? Buffer is a token, and its kind field says, is this a operator token? If so, if that's the print character, then we're going to just do two things, which are full equals false, and return. I think that's all we need to do there. And if there's not something in the buffer, if there is something in the buffer, or if the thing in the buffer. So if this is false, then we're not going to do this, right? But if this is true and that's not true, then we're not going to do this, right? So we're going to have to say, we're going to say full equals false, and then this is, I think, where we go into the little while loop for getting characters. So we're just going to use cin, okay? So let's make a character ch, and while cin ch, and that's not the well, I think what we can do is just say if that character is this target character, then return. Otherwise, just keep getting characters. Oh my goodness. Okay, I think maybe are we ready? We better be ready, because we got not much time. So here we are. We've got the output window, and I'm going to say 2 ampersand z semicolon. Whoop! I'm not typing here. 2 at sign z semicolon, and then 2 plus 3 semicolon, and we see bad token, bad token, bad token, crash, bang, boom. Oh. So it got the ampersand, said bad token. It got the Z, it said bad token. I don't know why I got 4 bad tokens. Okay, so cleanup mess has got to change, right? So cleanup mess, which is, I think, all the way down here, right? Yeah, this is just going to call the ignore function. So this is as simple as this. This is not naive. That's no longer an appropriate comment. Oh, and then we want to call it with with print, maybe? Does ignore take an argument? It does, doesn't it? Yeah. Okay. So let's try it now. Does it compile and run? There's our output. Well, sorry, I didn't. I wasn't showing you the code window there. All right, so this is 2 @z semicolon 2 plus 3 semicolon bad token, bad token. So it complains about the 2 bad tokens, but it recovers. I guess let's be happy that it's recovering. And since we're just about out of time, let's say that's a pretty good place to break off. And when we return on Wednesday, we'll do variables. And you can see there's quite a bit to talk about with variables, and having a vector of variables to reference, right? And then we'll get to the drill and the exercises for chapter 7, which is good because here we are in week is it week 13, I think, something like that. And let's go to our browser window. We can see how we did with sticking to the program. Is that here? Okay. Oh, the My Open Math. Well, can we just take a quick? I mean, not announcements, but assignments. If you go to assignments now, you should see two bunches of things here. We talked about this a little bit, right? The primetime one and the midterm part 1. And let's see. So if I open this up and I start the assessment, which of the following declarations is illegal and why? So these are pretty simple. I think you just put a check. So I think they're all illegal. How about that for a hint? And they're kind of obviously, right? So you can't define a variable name which starts with a number, right? So now this part I will have to read what you write here, right? A variable name can't start with a number. What else? A variable name can't be a keyword like double or a type name. Operators aren't allowed, and so on, right? In the variable name. So what happens if I submit here, having not answered it entirely? It gives me partial credit, right? Don't be alarmed by that. I mean, you got this part all right. This question contains parts, so you got 0.38 out of 1. Yeah. I don't know why 0.38, honestly. I'll have to think about that. But this is the kind of thing where I manually go in and look at your answers here. And so it requires human intervention. I try to build that into my software, just for job security. Next question. Yeah. And so these are little pull downs. This is a matching question. Can I then just get to the next question here? This is again a matching, but the list is down here, so you have to scroll down to get to the list. This took me a long time of like, oh yeah, how do you do the font family in the div section of HTML? And so you had to have monotype for the font family, and then if you want, like, you have to do a break and then spaces, and good God. All right. Oh, this one? This was not supposed to be here, but this was sort of an example of, so yeah, notice that it's got the template in here. Okay. Enter an tuple. So this was sort of a prototype which I was testing and forgot to remove. But hey, these are yada yada yada. There's your prompt, and 1 is a mammal, so a dog is a mammal. So you put a 1 here, and a cat is a mammal. That's, yeah, a bird is not a mammal. And a whale or shark is not a mammal. So there, I look at it. We have to, so you get free points for, and so then this requires another little essay section. And then these are just true false, right? So each one of these will either output true or not, right? And if it doesn't output true, then you can assume it outputs false. I didn't actually write that in there, but I think it's implicit, right? I think this one actually will be true, is that right? Because x is 2, and we increment x, we get 3. Y is 5. Oh, 4, I mean. And y, we decrement 5, we get 4, so those will be the same. Okay. You get the idea. All right, so we're out of time. Let me ask if there are any. Number 6 appears to be incorrect. It is missing a parenthesis. Oh, crap. Yes, I will post today's code. Be glad to. So is this number 6? It's missing a parenthesis. Which one? There's 8 of them, right? I wouldn't. Oh. Oh, they're in a different order. Yeah. They should be the same problems in a different order. Um, I'm hoping they're correct. If they're not, I'll figure that. D? Oh. Yeah, that one was complicated. I'm not very good at these Boolean expressions. All right, I'll double check that one. All right, so note to self here that maybe that needs to be fixed. And if so, then you get it wrong, I will forgive that. That's another power I have on the other side of the curtain, which is I get the last word on what your score is here, and I will attempt to build on this with more better questions. All right. Any other last? Yeah, I now remember to post the little bits. How about I'll post the calculator the way it is now, and our solution to the Watchdog. All right. Okay, I'll stop the recording here. And here. Oh.